Hello and welcome to the Intermediate to Advanced C# topics. In this session, we'll discuss object-oriented programming with C#. In this session, we'll discuss and introduce object-oriented programming concepts, and then in later sessions, we'll follow up with examples to really drive home your learnings. So, what is object-oriented programming? And why do we need it? The textbook definition of object-oriented programming is that it's a paradigm that relies on concepts of classes and objects. Object-oriented programming helps us structure our software to be simple, reusable code. In this context, classes and objects are different than the ones we've discussed in previous tutorials, where all classes inherit from objects in .NET. What is objects and classes in reference to object-oriented programming? Think of classes as blueprints. Let's use a construction example. So the blueprint of a house is equivalent to a class. Now, when we use the blueprint and construct a house, it's equivalent to an object. Let's use an example. Let's say we use a blueprint for a house and we construct two houses, blue and red. The blueprint doesn't tell us what kind of color the house is. When we construct these houses or instantiate them, a house becomes an object. So to reiterate this point, a class can define attributes but will not have any value. Once the class is instantiated, the values are set and we now have an object. We've seen our classes have methods. A house can be hot or cold, and we can call a method in passive value where the method will internally use an HVAC system to make the house hotter or colder. And in case you're wondering, HVAC is for heating and air conditioning units. So classes, objects, attributes, and methods are the building blocks of object-oriented programming. Now that we cover that, let's talk about the pillars of object-oriented programming. And there are four of them: abstraction, polymorphism, encapsulation, and inheritance. Inheritance, in short, is when class A becomes child of class B. So B inherits A. This means that we now have access to class A blueprint. We just reuse our class. Don't worry, we will dig much deeper with lots of examples in the next upcoming sessions. Encapsulation means we protect internal data to keep our classes stable. For example, if our house class and the temperature is controlled by the world and is accessible via an attribute, let's say current temperature, and we don't want anyone to change it, only if they use a method to increase or decrease the temperature, and that method internally uses the HVAC system. In this case, we protected the house current temperature state and allow to change it via our control method. Abstraction shows only the essentials of an object and hides unnecessary ones. This reduces the complexity of the object. In our encapsulation example, we used to control the temperature of the house via a method that called the HVAC system. So we abstracted the internals of how the HVAC system does that. Then what is the difference between abstraction and encapsulation? Simply put, encapsulation hides data, where abstraction hides complexity of how we manipulate that data. The last pillar is polymorphism, and this means designing objects to share behaviors. In inheritance, we had objects, attributes, and methods that were accessible when inherited. Now let's say we have a house that has an HVAC system, but we inherit a house with one that does not. So when we call the method to control the temperature, we instead open the windows and turn the fan that cools the house, and maybe turn on a portable heater to heat the house. In polymorphism, we share the house and the temperature control, but we now can override this method to do something different. Object-oriented programming forces you to think before you code, a term you'll hear often. It is good practice to try this. Anyone can code, but can you code so that your application stands the test of time? Doing this one particular practice will define you over other developers. Now that we've done an overview, we need to learn the C# access modifiers. So far, we have only covered public and private. Let's take a look at the chart that might help explain further all of the access modifiers. So let's quickly review the public and private access modifiers, then we can move on to the rest. So basically, public means that you can access it from any class or assembly, but also when inheriting. So let's see what that looks like, not just for the class, but for its members like methods, properties, and fields. So here we set up our project to test out different scenarios. We have our console app and an external library. We'll create a class with a simple method, property, and field. Since everything is public, we should have access from anywhere. If we test our scenario, you can see that we can access the class and its internal members due to public modifier. We can also access the class and its members if we inherit from it. Now let's try accessing it from a library external to our project. And as you can see, the same results. Now that the default class we created has no access modifier, so the default for the class that has no modifier is private, but in this scenario it'll be internal. We'll see that in just a little bit. Okay, now let's take a look at if we remove the public modifier and add private. Immediately the compiler throws errors, and now this makes sense because why would you create a private class that no one can access? So it is not allowed to create a private class inside of a namespace. Now you think, well, let me put it outside a namespace. Remember that removing the namespace will put the class in the default global namespace. We went over the global namespace in our other videos on class introduction. So how do we know that not having a modifier in a class is internal? This will always be true if the class resides inside of a namespace. If we open our project viewer, we can see the internal access modifier. This is added for us when we compile the project. It's a little confusing, but hopefully you get to know the distinction. So then how do you create a private class? You do that inside another class. Remember, you can nest classes. Because it's private, only the class that holds it can access it, and no other scenario. So the question is, why would you create a private class inside another class? This is to structure your code so that you can keep your structure different from the class that you're exposing to the world. So the public access modifier was open to all access, and private is the opposite, and the least accessible and can only be accessed within the body of the class. Let's make the public modifier private and see what happens. And now we should be able to access these from the same class, and as you can see, we can access it and set some values to it. Same thing with a property. So this is great. Now let's go look at our test2 class, which is inheriting from that class, and as I can see, none of the methods or properties and fields are accessible because it is private, even though we're inheriting from it. Now if we go to our program library and try to see, it'll be the same thing. You should not see any properties, fields, or methods, and as you can see, we do not see that. Now let's take a look at the protected modifier. Protected is one level higher than private. It means that the class and the inherited class has access. Now, as before, let's update the properties and see this in action. So now that we have access to all of the fields properties, let's take a look at the inherited class. And as you can see, the inherited class is not complaining, and we are able to access the properties, methods, and fields. Now if we go to our program class, which resides inside of our the test class, which is in the same assembly, and as you can see, we have our test, and we do not have access to any of the properties or fields or methods. The same will be true if we go to the class, which is outside of it's a different assembly, and if we go here, we do not have access to any of its properties, fields, or methods. So now if we go to the test class and we say we make this protected, this will not be allowed. So we get an error as before. So this is same as having it private, which means that it doesn't make any sense to have protected on a class that no one else can access. The next modifier is internal, and by now you should have a good idea what's coming. Internal is one level higher than protected. Simply put, only the internal assembly can access the class and its members. So whatever assembly the class is compiled is going to have access to it. If we change the modifier now, we should have access to the class members, and everything should be accessible from the class that the assembly will compile. Next, if we set the class modifier to internal, it should be the same result. This time, we cannot access it from an external assembly if the access modifier is internal. If we put the public modifier back to the class, as you can see, we cannot see any of its members that are internal from the external assembly. So the next access modifier is the protected internal, and it works the same way as internal, but with one difference. The external assembly can access it only if its class going to inherit the class from another assembly that is protected internal, and that's the only way you can get access to its members. Now the last access modifier is private protected. This works the same way as the protected internal, But unlike the protected internal, this is only for the assembly that the class resides. So that means the only classes in the internal assembly can inherit and have access to the class's members. You're probably wondering why we went over the access modifiers with regards to object-oriented programming. That's because access modifiers are keywords in the C# language that facilitates the encapsulation, abstraction, and other parts of object-oriented programming. If you've been following our channel, you know that we try to get you started with a strong foundation on the topics. We also start with just an introduction to the topic and slowly introduce other areas so that you learn and retain the subjects covered. With that said, thank you for joining us for this session, and we will continue with object-oriented programming with some real-world examples coming up in the next sessions. So have a wonderful and safe weekend. We will see you in the next session.